Hi, hello everyone. So last time we left off with our textures, and we had this kind of basically tiled textures, and we learned a bit about uniform buffers. And this time we're going to continue with that, but we're going to cover transformation. So we're going to cover basically matrices and how can we transform our geometry being basically this texture, and how can we move it, how can we scale it, how can we rotate it. So let's get to it. So for that we're going to use, like I mentioned, matrix, and it's going to be matrix 4x4. And if I go to our shader, so I'm not going to spend too much time actually explaining matrices. I do assume that you know something about matrices, but I'm going to explain matrices that we do and how we do them. So like, this is not a starter on linear algebra, but we're going to explain those matrices that we're going to use. So with that said, first thing, we're going to go to our shader, unlit material shader, and here we're just going to make our texture tiling, and we're going to move it to binding 2 because we're going to use binding 1 for our, binding 0, we're going to use it for our model matrix. And here, should I call it model matrix? It's a good name. Well, I usually call it transform, so I'm just going to stick with it, but you can call it model matrix. Now everything is broken, that's quite alright, because we still don't use it, but here it's matrix 4x4. If I could type, that would be awesome, and I can. And so where does our matrix belong to? Well, it will be so we're going to use it to get the final position. So we're going to do our transform times and this vector, so this will give us our final position. And the first matrix that we're going to cover is identity matrix, but first we need to pass it. So let me think for a second. So we're going to do it like that. We had a mat class, so we're just going to call this matrix 4x4, and here we're going to export class matrix 4x4 extends, so it needs to be typed array, and here I'm just going to say constructor. So by default we're going to actually create identity matrix. So what does identity matrix looks like? Well, it looks like this. So diagonally we're going to have ones, and 0 0 0. So it will be 4x4, 4 rows, 4 columns, and diagonally it's all ones. So you probably already know it's like some important properties of matrices in our context, since we're multiplying here by a vector. So if we multiply our vector times identity matrix, so this being the matrix, we're going to get original vector, right? So same is if we do it other way around, so we're going to get our original vector. So it's like multiplying by 1. Alright, and same is when we have a matrix times identity, right? We're going to get them. So those are some properties of identity matrix. And with that said, now we need to do all this small stuff in our unlit render pipeline to actually pass that matrix. So let me take a look at the nodes here, because there is quite a bit of small stuff to do. So here somewhere before our texture tiling buffer, we can say private. We're going to need transform buffer of type uniform buffer. We're going to need transform, and we're going to have public setter. And as usually, right, we set the value of transform and then we update it. And here I just need to say import. This is quite right. And here we had texture tiling bind group. I'm going to rename it. I'm just going to call it vertex bind group. I couldn't think of better name, so I'm just going to call it vertex bind group, where we had texture tiling. So we have transform buffer, transform value, which is set to identity matrix by default, but it's not important. So next we're going to create our transform buffer, and we're going to pass transform, and we can just say transform here. So further, once we find our vertex bind group layout, so texture tiling, so it's not going to be texture tiling anymore, so we can rename it vertex group layout. Alright, so binding 0 is used, it's actually, we can do this, and then I'm just going to do this. So we have binding 0, which will be used for our transform matrix, and binding 1, which we moved and will be used for our well, texture tiling value, right? The thing that does tiling needs to be in vertex shader, and the buffer can just, we can leave it default object here. And then somewhere at the end, when we were setting these groups, so we have our vertex bind group, so this one becomes 1, and at binding 0 is going to be our transform buffer. So now it works because we already filled the value of our buffer, right? So we had identity matrix, which is now multiplied by vector, and we get a vector, right? And that's it, I think. We don't need to pass anything else. Yeah, it already works. Great. So further, we're going to do some other matrices, which might be interesting. So we're going to go to our matrix, and first one I'm going to create, I think we're going to start with translation. Let's see. Yeah, let's just go here, public static. So we can just create identity by default, but here create translation matrix. So here it suggests vector 3, we could use that, but I'm going to do it like this, number. Alright, let me just move this a bit. We're going to return matrix, and here I'm not going to do it like that. We're going to do it like this in the future. We're going to optimize it a bit, but for now, for clarity, I'm going to use unoptimized values. So translation matrix, and this is wrong suggestion because we're not in row, we're just going to reverse row and columns here. This might depend, right, on your software, if it's a column major or row major. So some APIs are row major order, some are column major order. In this case, I believe we're column major order. So what are we doing here? Well, if you look at here, these values are the same as identity matrix, but actually translation is saved here. And often I will get a question, why do we have, for example, why do we have this one here at the end? And this is exactly the reason why. I mean, there are some other properties of this one which we're going to cover in future, but one of the reasons is because then we can do translation easily, right? So if I was to return to matrix here, you can see we need this last row in this case. Here is where we save the translation value. So what do we have here? For example, let's say that we have vector 1 0 0 1, right? We just have an x. We can have a y, and here 1 1. All right, maybe I should do that again. So let's say that we have some vector 1 1 1 1, and then we're multiplying by some translation matrix, right? We had 0 1 0 0 0 0 0 0 1. Sorry, 0. Here it's 1 0 0 1 0, and then we had x, y, and z, right, for translations. And let's say that we want to translate instead of x. Let's imagine 2 here. We don't want to do anything for y, and we don't want to do anything for z. And here it needs to be 1, right, by default. So because we're multiplying, right, rows times columns, so we have this 1 multiplied by 1, we get a 1. So then we have 0, 0, so it's basically plus 0 plus 0, right? Y is multiplied by 0, z is multiplied by 0, and then we have a 2. And then this for this 1, right, we multiply by 2, and we have a new value for x, so this is just an x, which is 3, right? And then it's same for here, right, if you know how multiplication this works. But you can also play with it. For example, I have example here, right? There is this nice tool which I'm going to leave in the description of the video, but you can actually here, for example, I have created our vector, and then I have created translation matrix, and you can see how it works, right? So we're translating by 2 from position 1, therefore we get 3. We're translating our y is at 2, we translate 2 units, right, and we get a 4. So that's how it works, and now maybe we can use it. Right, let's see if it works actually. So in our main, we can just do it here, only pipeline, transform, it's matrix 4 times 4, create translation matrix. We're not going to translate everywhere, so it should stay the same position, but we can translate by, let's say, 1 unit to the left, and our images move to the left. If I was translated, let's say, 1 unit up, it's up now. Okay, that's how it works. Easy. So the next one is, we can just cover scale matrix really quickly. That one is easy as well. Public static create scale matrix. So we have our x, y, and z. And here suggestion is wrong. Apparently, Copilot doesn't know how to create matrices. So let's just fix this. So our scale matrix is x is where our 1 usually is. Here is y and z. So it's ordered kind of diagonally, right? The values. So if I was to go to our main, let's say create scale matrix, and let's just do this. So we're just going to scale our x, so you can see how squished it is. If I was to change x to 2, right, I would stretch it. If I was to change it to 1, we get our original image back. So it kind of same applies for y. Let's try it here. If I do y, it's stretched up and down. Okay, cool. Easy. So once again, I would recommend to play with this tool as well. So the scale matrix would look something like this. Let's say that we want to scale 2, right? So we get 2, right? Our x was 1, we're scaling by 2. Our y was 2, we're scaling by 2, therefore it's 4. Our z is 0 because it was 0, right? This scale doesn't matter if this one is 0, and then the 1 is not important here, so you could essentially use matrix 3 by 3 for scaling a vector, but for translation, right, for this moving of a vector, we need 4 by 4 because the values are in last row. So that's one property of vectors and matrices. And then the last one that I want to cover is actually not that hard. It's just rotation around the axis. So for rotation, if you remember, maybe if you ever did rotation around point or something in high school, it has this formula x cosine of angle minus y sine of the angle, and then y times cosine of the angle, blah blah. So we can just copy and paste that kind of into, but we're just going to create it in a matrix form, right? So we can do it like this. If we go to our matrix, I'm just going to call this one. So same as high school, right? We're just going to have it in a matrix form here. Create rotation matrix z. So we're going to rotate around z. So we're going to need sine, and then we're going to need cosine, and then we're going to need matrix, and I'm going to say matrix set So how do we do that? Well, if you look at here, x needs to be multiplied here by cosine, right? So we're just going to say cosine of angle. Then we have minus sign, right? And then 0, 0. Then we had for x sine, cosine, 0, 0. So we're rotating around the z axis, therefore it's 1 here, right? If you were to rotate by some other axis, it would look a bit differently. And I'm going to showcase at the end other matrices, other rotations as well, but we're not going to do them. And then I'm just going to say return m. Create rotation matrix Z. So if I was to go here, and I'm just going to rotate it by 0.5. Let's see if it works. It is rotated, but you can see it's a bit skewed here. So we're going to cover that in future, right? This skewing, but for now, I'm just going to say it's because our width and our height are not the same, so therefore it's a bit skewed. So if I was to change this, our width to 720, so that the aspect ratio is 1:1, then it's correct, right? The aspect ratio needs to be 1:1 here. Okay, with that said, let's just try to rotate it so that we see that it is in correct rotation. So here I can just somewhere outside of init, I'm going to say let angle is 0, and then when we draw here, we have that is unlit pipeline. I'm just going to say unlit pipeline transform, and then I'm just going to increase angle by this amount, and it rotates. So our rotation is going, this is clockwise. But if you want to go counterclockwise, you can just go to our matrix here and just switch this sign, and then it should go counterclockwise, I think, and it does. But I'm going to leave clockwise rotation. All right, that's it. Hopefully you got everything that you need from this video and hopefully you understand this. Basically rotation, translation, how it works. Hopefully you understand why we had this, right? When you have vector, usually you have x, y, and z, and then you have 1 in the shader, and this 1 is used so that we can multiply by this row, right? Because when you multiply columns times rows, rows times column, each one of those, right, corresponds to this. And then this, and then this, and then the second one is y, blah blah. You get the idea. There are some other properties as well, but one of the properties is this. For our scale matrix, it's quite simple. Scale matrix is probably the simplest that there is, aside from identity matrix, and then for rotations you can use this. And then I promised also that we're going to take a look at some other rotations. Rotation around axis. So let's see, will it suggest ones? So yeah, you can find them here, right? We used around z-axis. So these are in 3x3, but you can extend it to 4x4. You just add zeros to last column and the last row, and then just the corner is like 1, right? Like it is here. So you can easily extend it to 4x4 if you want to add other rotations to your code. Well, that's it for this video. Hope you enjoyed it. If you enjoyed it, please like, subscribe, and until next time.